Hey everyone, my name is Ronak, back with another video, and in this video we had learned recursion. Now in this video we are going to cover linked list. So linked list is, I would say, very big concept, and it is going to take a lot of time in order to cover all the things. So what I've decided is I will split this particular concept into two parts. In this video you are going to learn the basic concepts and whatever operations you can perform on the linked list and implement all of those in the Python. And in the another part we will cover all the most possible and more frequent Leetcode questions that can be asked for the linked list. So starting with the concept of the linked list. So this is the first video, okay, where we will be doing a lot of conceptualization, understanding what really is a linked list. So till now we have seen array. Essentially it is a list of series of elements. Now when you check the context of another languages, there is a problem of contiguous and non-contiguous memory. Linked list is also a type to store the data, but you have separation among all the elements, and there is a linked connectivity between those elements. So essentially it is just like an array, but here the concept changes from being held into one particular space to having a dissociation with a series of elements. So all the elements are connected to each other based on the links between them. That is the reason it is known as linked list. At the end it is a list, okay, but it is linked. So some operations, if you particularly ask me, perform way good than the arrays. Okay, so both have their own merits and demerits in the sense of, let's say, space and time complexity. Anyway, so one entire piece which actually stores the data in the linked list is known as node. Okay, it is known as node. And this node will be having two sections, one of which is your data and one of which is the linkage to the next node. Because if we think about it, you have to connect this particular node with this node, and in such a scenario the way you can connect is you will have to store the address of your next node's data with the current location. So creating an association between both the nodes. So one of them is known as a data and another part of it is known as next. So this next particularly holds the address of your different node. And in a generalized linked list, if we talk about this, okay, so dn connected with another, let's say dn, which is data and next node address, data and next node address. The last one is always null. Okay, it is always connected to null. So the last node particularly is known as tail, and the front from where it actually starts is known as head. Okay, so now we will look how you can implement these things using Python. So let us now think of this like a connectivity concept. Okay, so the only thing in Python that you require to be strong is basically your object oriented knowledge. Okay, object oriented knowledge, nothing else. And what I expect from you is to know the association of class and objects. Essentially you can consider class as a blueprint of something, okay, and object can be in very, I would say, many different dimensions which actually adhere it themselves. Okay, these objects adhere to the rules of the class. Okay, so whatever your class represents. Okay, so let us take an example. There can be a class which actually states that the language needs to be object oriented. Okay, so the languages that are object oriented can be in many different dimensions. Okay, so it can be, let's say, Java, then CPP, and one more object oriented concept you have in Python also. Okay, so now these three languages are object oriented. Okay, so being object oriented, being object oriented is the feature of the language. Okay, it is a feature. In such a sense, are all of these three adherent to that feature? Yes. So they follow the blueprint of the class. They stick to what the class is actually trying to impose on them. Okay, so objects can be also referred to as a subsets of those class. They follow the properties. They follow the properties of the class. So now the way we work with a linked list is we are actually going to make objects out of it. Okay, so we will create a class node. Okay, a class node, and this node essentially will contain data and the next. Okay, and initially this single class will be just by itself, it will be independent, and then you will create another class known as linked list, in which you will mention the specifications of this, to where the head will be connected and how they will be interlinked. So let us start by writing some code. So in the Python, I have made linklist.py. Okay, as simple as that. So class, I'll say node. Okay, class node, and it is always going to have a data and the next. So start by making a constructor. Okay, now I'm not going to go into the depth of the constructor, but you have to understand that constructor essentially is a method that is invoked when you create an object of the class. Okay, so by default it is going to run. So self.data is equal to data. Okay, so now this is going to be the data that I'll be passing to the node. Obviously, because if you think about it, this data essentially represents something. It can be, let's say, a number, a character, and whatnot. Okay, it will contain a data, a type of data. So self.data, so self is an indication. Self works like this keyword in the Java. So this self.data is an indication that this is a property of this particular class node. So whenever I invoke the data, the D part in this, okay, the D part in this and the next part, both these parts will have a particular association. So self.data is equal to data, which is the data that I'm actually passing. I can also call it value. Okay, value, in order to clear the things. Okay, self.data. So the D part of your particular node is the value, and then self.next is equal to none. So we started by keeping it none. My class is now created. Okay, so essentially now what I have done is I've created a node class. Now whenever I invoke this class, the data part, the self.data, is going to expect a value that I'll be feeding from the output, and the next element will be null by default. Okay, it is connected to null. So whenever now I create a linkage between the another node that I'll be creating, I will be associating it. I will make a connection between them. Okay, now let us make class linked list. Okay, now this class is going to enclose all your nodes. So here also you will require a constructor. And now in this constructor itself, I'll say self.head, which is also essentially equal to none, because now I have again created a new class named as linked list, which has a constructor which will invoke when I call it with the self.head. And I will connect this self.head to the first node that I'll be creating, the first object that I'll be creating. Because in order to get a linked list working, you always require a head. Okay, to ensure that this is the start of my linked list. Okay, so this is the way it is done. And now I will say if name is equal to main, and over here I can make the object. So let's say LL is equal to the object for the linked list. And now you can actually associate methods and add data to it. So the first thing that we actually want to see now is how you can enter the data. Okay, essentially insertion in the linked list. So let us try to keep things as simple as possible, and then I will progress slowly. Okay, so let us make a function, let's say insertion. Okay, insertion. The insertion will actually take self and a new value. So this value essentially is going to be your data that you are going to fit to the linked list. So let us say data itself to keep things simple. And now I'll say new node is equal to node, which is the class that I've created earlier, and I'll feed it my data. So essentially this value is equal to the data. Okay, the parameter value over here that actually associates itself with the self.data, the D part of your node, will be essentially the data that will be passing from the insertion function. And now I can pretty much say new node dot next is equal to self dot head. Okay, and then self dot head is equal to new node. Okay, so now let us try to understand how we actually insert the data in it. Okay, we will use this example itself. First, it starts by making a node. Okay, so it actually expects, let's say when you say insertion and pass it a value. So let us say 3. 3 is the value that you want to pass. So the first line, which is essentially new node, is equal to node, the value passed is 3. So now this value is your self.data. Okay, so a node is created with 3, and now this is currently pointing to the null, the n. N essentially is pointing to the null. Okay, this n. In such a scenario, it says new node, that is this one which is created dot next. Okay, dot next. So the next part of this new node is essentially equal to self.head. So now this self.head is a constructor invoked from my linked list class, which is an indication that this is the starting node. And now I will associate the self.head is equal to new node. So after the creation of this object is now associated with the self.head. Now if I want to insert a new value, let's say 2, it will say new node, essentially this particular object of this class is going to take 2 as its self.data. Okay, it's going to take 2 of its self.data, and then it will first say new node dot next. So dot next essentially indicates next for this particular node. So now again a new node will be created and a link will be done to this, and this self.head will be transferred back to the 2. Now let us actually try to run this to understand it way better. Okay, so I'll say ll, which is the object for the linked list I've created, and I'll say insertion, and let us pass it 1. ll dot, let's say insertion, we have to pass it 2, and ll dot insertion, we have to pass it 3. Now let us run this. Okay, so no errors at the moment, because even though we have inserted elements, we have to print them. Okay, so traversal is very important. Okay, essentially traversal is you walk through the particular linked list that you have in order to print the stuff. Okay, so let us say def traversal with the self attested. Okay, and then let us say current is equal to self.head. Essentially current is an element where it starts from the head. And now I'll say while current is valid, I'm going to basically print the current. Okay, I'm going to print the current dot data. Okay, and I'll also create a link between them. Okay, to look it more appealing, nothing else, nothing fancy. And when the particular data of that value actually of the current is printed, I'll say current is equal to current dot next. So essentially I'll be pointing to the next node, and in the end I'll print none. Okay, so since it is connected to the null, and now let us say ll.traversal. Now let us try to run this. It gives us 3, 2 and 1, and then it is connected to none. So now let us look this how it will actually work in the whiteboard. So the insertion is there. Let me first get rid of this. Insertion is there. First we enter 1 in it. First we enter 1 in that insertion. Now a new node is connected. Okay, so new node is an object. Okay, it is an object of that node. Okay, because it is taking the one value in it. And now I will say new node dot next, which is currently null. Okay, which is currently null, has been attested to self dot head. So self dot head essentially is pointing to the new node dot next. The next, essentially the next of this. Okay, the self dot head is over here. And now I will say self dot head is equal to the new node, which is my object. Now my head is over here. Now I insert a new element. I say 2. Okay, over here also I say 2. It says new node dot next. New node that has been created dot next is equal to self dot head. Okay, so now it is pointing it. It is actually pointing to it. And then I'll say self dot head is equal to new node. Okay, the new node that was created, now head is this, and this is gone. Then I enter 3 in it. Again a new node is created with 3 and n. This is first connected and the head is transferred over here. So this is start of the node. Okay, this is the way it works, as simple as that. Obviously this is not a conventional way, and I will show you one more way with which you can actually show it. Now let us look at the traversal. Okay, how traversal actually works. So it is a self-attested method. You don't require anything in it. So you first start with the current. Current essentially is self.head, where head is pointed, which is your first node essentially. After that, I'll say while current. Okay, so while the current is active. Okay, so while the current is placed that the self.head is in it, I'm going to print the current.data. So first it prints 3. And here after printing in print, I've also said after the current.data, I've also said end like this to create an appearance of the node. Okay, so it actually points to something. And then while the current is active, I'm going to change the current to current.next. Okay, so essentially the current was over here. Now it is transferring the current over here. Okay, so this node changes. Okay, so it will run all the way to 1, and when in the end, as a base condition, it is print none. So none essentially is your null when it reaches the end. So this is the way the traversal works. Now in the last tutorial, I had shown you a recursive way. So you can also convert any of these functions into recursive. Okay, so let us say df recursive traversal. Okay, starts with self, and it is going to require current because we are going to invoke the function over and over again. So essentially I start by printing. So I'll say current dot data followed by the end, where I'm going to say like this. Okay, just to give it an appearance of the linkage. And I'll say if current dot next is equal to none, okay, which is essentially the end, I'm going to print none. And essentially break out of the loop. So this is my base condition, and in the background it is going to keep running. Okay, so self.recursive traversal with the next of the current. Okay. So now this is a recursive function. I can also make a change over here. Okay, so let's say ll.recursive traversal with the ll.head. Okay, and now let us run this, and it prints the same. Okay, I can also change the ordeal sequence in order to ensure that this is working. Okay, so let us say 3 2 2. I run it, it says 1 2 3. Okay, so essentially the insertion of the elements is in the not appropriate order. Now let us look at that also. Okay, so essentially traversal is done, insertion is done, but this insertion I want that the element that I'm entering over here should be the first element, and it would then move sequentially, and the element should be added to the back of it every single time, not to the front. Okay, so this is essentially insertion to the front. Okay, insertion to the front of the element. Every time you enter something, it is going to go to the first element. Now what I want is insertion in the back, essentially the way it is supposed to be. Okay, so it is going to take self.data. Obviously you are going to start with the self.data. So as usually we will create a new node which is an object with the node, and pass it the data, which is essentially your value, the d, the self.data. And now I'll say if self.head is not available itself. Okay, if the list is empty, I'll say self.head is equal to none. Okay, this is the base condition. Else, okay, else I'm going to say current is equal to self.head. So whatever is actually held, I will assign it to a variable name as current, and I'll say while current dot next. Okay, so while the current dot next is available, in such a scenario I'm going to say current is equal to current dot next. Okay, so we are going to traverse through the entire linked list. I will also show you how by drawing the solution. And current dot next is equal to new node. That's it. Okay, so this is the way you enter. And now I will make a change. Okay, so it is I have named it insertion. Okay, and I have changed the first one to insertion to front. So now let us run this. So now the output should be 3 2 1. Okay, so there is an error. Let us check. Okay, so something is wrong. Okay, so self.head should be new node. Okay, because that was the mistake. Okay, so now it says 3 2 1, and I can now change the order. Okay, so let us say 1 2 and 3 like this. Run this. It gives us now 1 2 3. So whatever elements you will be inserting will be inserted in the back every single time. Now let us actually look how this piece of code is working. Okay, let me actually copy this itself. Okay, so code is now copied. Let me change the color. Yes. And now let us work with this. So first, whenever I create an object, okay, let's insert first 1. So new node, an object is created. Okay, so let me draw itself. It will be better. Okay, 1 over here is created with the n, which is now currently pointed to null. So now if the self.head, if not self.head, it is currently not available, we will assign it to the new node. Okay, so now this is my head. Okay, now next I insert 2 in it. So if not self.head, okay, so now it is available currently. So I'm going to check for the else condition. Here I'll say current, which is, so I will make current pointer, which is essentially pointed to the self.head. And while current.next is available, yes, it is now currently pointed to the null. I'm going to get rid of this, and I'm going to say current is equal to current.next. Okay, so now whatever this is pointing to, the null, the current comes over here, and this is gone. In such a scenario, it is going to say current.next is equal to new node. So now a new node will be created. Now I enter 3 in it. So head currently again is pointed to the 1. So it will go, the current starts from the 1. Then it actually passes itself to the next node. Then again it passes it to the next node. Apparently this is now pointed to null. Apparently this is pointed to null. In such a scenario, the current will be transferred over here. And whatever now current.next is expecting, 3 will be given and a new null to be connected. So this is the way it works. And a traversal is typical again. Okay, so I have already shown you. So this is the way this piece of code works. Now this is the way you insert something and delete from your linked list. Now let us try to search an element in the linked list. Particularly searching operation in the linked list, okay, and a new logic will be required. So let us write some code. So let us say def, making a function, let's say search, and it is going to require, let's say, the target. Okay, so let us only return the boolean at the moment. So I'll make first current, which is equal to self.head. Okay, so it is first connected to the head. After that, I'll say while the current is active, okay, all the way, if the current dot data is equal to target, as simple as that, I'm going to return 2, which is essentially a boolean response. If not, okay, I'm going to check for the current dot next. So this is the way we are going to traverse through the entire linked list, and the base condition is obviously going to be return false. Okay, my search is done. So now let us say ll, which is the list search, and let us try to search 2. Okay, so it is a boolean response. So let's say response. So it is either going to be true or false. Okay, and I'm going to print this response essentially. So let us run this. Okay, it says true because 2 is available. If I, let's say, 4 over here, an element that is not available, it is going to give me false. So this is the way it works. Okay, search. This is very easy. Okay, I don't think I will have to draw solution representing it that. And now let us look at one more operation, which is essentially deletion. So deleting an element from the linked list. So let's say there is an element that I want to essentially delete. So starting with, I'll say current is equal to self.head. Okay, so I'll be pointing to the head, and I'll say while current dot next is available, if the current dot next dot data is equal to the element that I actually want to delete, I'll say current dot next is equal to current dot next dot next. Okay, so I'll be taking the condition that is available to us and pointing it, and I'll essentially return. Okay, but this is not sufficient. Okay, and since this is traversing, we will always have to check current is equal to current dot next. I will draw this solution for you so that you will understand. And I don't think this is sufficient, so you will require some base cases for it. So let's say if not self.head. Okay, if self.head is not available, I'm going to return. So essentially there is a thing to delete. And if the self dot let's say head dot data is equal to the element that I want to delete, essentially, so I will say self dot head is equal to self dot head dot next. Okay, so it points to essentially in the blank space, and I'll just return this stuff. Okay, so the two base cases are now ready, as simple as that. And now let us say ll dot delete deletion, and I want to delete 2, and then again I will traverse the linked list. Okay, so let us run this. Okay, so first 1 2 3 was enter, I deleted a 2, it was gone, and now we only have 1 and 3. It actually works. Okay, let me now try to delete 1 itself, which is the first element. I will run, and it says 2 and 3. So now let us actually draw a solution for this. Okay, in order to understand this function much better. Obviously it seems a lot of bit confusing. Okay, so we have it. This is my function. Let me make it white. Yeah, so now we have the deletion. So let us start by making a very, I would say, simple linked list. There will be node 1n pointed to the address 2n, and let's say 3n, and this is null. So I essentially want to delete the second element. So let us say if not self dot head. Okay, so essentially the head is pointing over here. If not self dot head, okay, I can directly return because nothing is there. So this is not fulfilled because I want to delete the second element. If self dot data, okay, is equal to element, is it available? No. In such a scenario, I'm not going to do anything at all. So first I start by current, and while current dot next, okay, while the current dot next is available, if current dot next dot data is equal to element. Is it equal to element? Yes. I'm going to say current dot next. So current dot next, this element will be now point. So this connection essentially will be pointed over here. Okay, to the next of next. Current dot, so this, let me use a different marker. This is current dot next, this is current dot next dot next. So I directly make a connection over here. So essentially this has been now deleted because all of the objects are connected with a linkage. And if I remove one link, all of the sudden this is lost. Okay, this element is lost. This object is now directly trashed into memory. Okay, until you run the program. So it will directly go over here. Okay, so this line current dot next is equal to current dot next dot next. Okay, directly points to the next dot next, and then it returns itself. Okay, so it actually breaks because when I start with the 2. So let us now take one more example. So let's say 1n connected to 2n connected to 3n connected to 4n. Okay, 4 elements, and in the end you have null. So over here you have head, you make this a current, and let's say I want to delete 3. In order to delete the 3, it will go to the current dot next. Okay, so now current dot next will be over here, and after that, because since this loop is moving, okay, so this condition was not satisfied. In such a scenario, I will say current is equal to current dot next. I'll point my current to this. In such a scenario, now again I'll have to delete the third one. Okay, so if current dot next dot data, which is this 3 element, is it equal to the element that I want to pass over here and delete? Yes, I want to delete 3 apparently. So in such a scenario, I will say current dot next, which is essentially this node. I will break it and link it over here. So now this is deleted. It is in your memory until the execution, but that connection establishment is now deleted. It is gone. Okay, so now the linkage will be like 1 of n connected to 2 of n connected to 4 of n, which is connected to none. So this is the way it works. And now this is somewhere hanging out there. Okay, it is now when used for the garbage collection. So this is the way it works, the deletion. Okay, so these were some of the basic methods in the linked list, and this was actually also the way with you can create a linked list. Okay, you can create a linked list in the Python language. Okay, so first we started by creating a node. Then, so node essentially is a class enclosing the features of the data and next, and the head was the place where I create a linkage of the linked list, which can be linked to one another after inserting one by one. Okay, so that linked list will create that necessary amount of link in order to connect all of those objects created of the node over here while insertion. So we inserted to the front, but a practical solution was inserting at the back of the element a single time. So we also saw that, and traversal is very typical. And I also converted this equation into recursive function. Okay, so if you want to try, you can try the recursive functions by yourself. Okay, recursion we have covered till now. And then we actually searched for an element that is available in the linked list by returning just the boolean, and we also performed deletion, which is essentially deleting an element that is available to us. Okay, so this is the way it works. So, and this is the main method. Okay, so I will upload this code for you along with this whiteboard stuff that is also shown over here. Okay, so I hope you might have learned something or the other. So this was the basic of the linked list. Okay, we could solve a lot of questions, but I think we should reserve a new tutorial for this, where we will actually cover a lot of typical Leetcode questions which are asked on the linked list. Okay, so linked list prioritization, I would say, is very important because now this class and object association and the concept of using a node in order to connect a linkage between will be used in the trees and graphs. That is the reason I had to cover linked list no matter what. Many people cover linked list at the very end, but my personal experience is that you should probably cover it after the completion of array. Okay, once you get the hold of, let's say, entirely and the recursion concept, because recursion is used a lot in trees. Okay, and even in the some linked list problems, we will try to cover some linked list problems that actually require recursion for you to solve the issue. Okay, so we will now in the next upcoming tutorial solve a lot of problems. Okay, so this was the linked list first video. Okay, so I hope you might have learned something or the other, and in the next one, obviously, I will see you with the linked list problems. Okay, so this is where we stop, and I hope you might have learned something or the other. And please, if you like my content, please do subscribe to my YouTube channel so that you can always stay updated, and share it with the friends and keep going. Okay, so thank you for watching. Goodbye.